Hi everyone, I'm Balaganesh and today I'll be giving an introductory lecture on the topic of inverse trigonometry for class 12 CBSE. So let's get started. So to begin with this topic, let us first revise the conditions under which a function is invertible. So let us say we have a function f which has a domain A and codomain B. The elements of x are of A are denoted by x and the elements of B are denoted by y, let's say. So we say that the function f is invertible if f is first 1 1, which basically means that every element in the set A is mapped to a unique element in the set B. That is, there should not be two distinct elements in the set A which are mapped to the same element in set B. And the second condition is that the function should be onto. And that basically means that the range of the function f, that is the set of possible values that it can take, should be the same as the codomain. There should not be any element in set B that is not mapped to any element in set A. That's basically what this means. So under these two conditions, the inverse of the function f is defined as f inverse, and here the domain is B and the codomain is A. So these two are interchanged, and it satisfies the following two properties. That first thing, f inverse of f of x is equal to x for all elements x in the set A, and also f of f inverse of y is equal to y for all the elements y in the set B. So that's basically that those two other conditions, the properties that are satisfied. The topic is inverse trigonometry. So as the name suggests, we are trying to define the inverses of the trigonometric functions. So, however, consider the sine function, for example, first. The domain is the set of all real numbers R, and the codomain is the set of real numbers again. Basically, we realize that this function is not onto, since the range of the sine function is just this interval from -1 to 1. The sine function cannot take any values outside this range. So the range and the codomain are not the same, so it is not onto. However, we can easily make this function onto by redefining the range of the function like this. So now the codomain and the range are the same. So we have defined the sine function such that it is an onto function. But the other thing is that all the trigonometric functions, not only the sine function, they are all periodic. So they are not one to one. So basically, as an example, the graph of y is equal to sine x looks something like this. So the values just keep repeating themselves, and you can see that there are multiple values of x corresponding to the same value of y. So it is clearly not 1, 1. However, we can, by restricting the domain of this function, we can make the function 1, 1, 1 like this. See, this is y, this is 1, this is -1, this is minus pi by 2, and this is pi by 2. So now if you see in this interval minus pi by 2 to plus pi by 2, the function is strictly increasing in this interval, and it is clearly 1, 1. So what you can see that there is no repetition of values in this interval. So what we do is that we define the domain of the function to be minus pi by 2 to pi by 2, and now we have the sine function as a 1, 1 and onto function. So now this function, we can easily define the inverse of this function. Like, so what happens when we define sine inverse? The domain and the range get interchanged, isn't it? So we have, so the domain here is -1 to 1, and the range is this minus pi by 2 to plus pi by 2. So yeah, this range of values which we have selected, this is commonly known as the principal value branch of the sine function. So that is basically how we have defined it. We can define the inverse of all the trigonometric functions. So yeah, we rewrite the sine inverse function definition. So we can similarly, you can define the inverses of all the other trigonometric functions. So for cos inverse, remember for the cos function, the range is -1 to 1. So that means the domain of cos inverse will be -1 to 1, just like the sine inverse. And the range here will just basically be the principal value branch over which the cos function is 1, 1. As it turns out, the most convenient choice for the principal value branch here is 0 to pi. So then, yeah, so this is the definition of the cos inverse function. Now, for tan inverse, remember that the range of the tan function is all real numbers. So that means the domain of the tan inverse function will be all real numbers. Now, again, if you recall the graph of tan y is equal to tan x, then then in the interval minus pi by 2 to plus pi by 2, the tan function is strictly increasing, and you can choose that as the principal value branch. However, the endpoints minus pi by 2 and plus pi by 2 cannot be included because the function becomes undefined at those points, if you remember. So we use the round brackets here to define the interval. Next is cot inverse. Again, the range of cot is all real numbers, so domain of this is all real numbers. And then again, you can choose here the principal value branch can be chosen as 0 to pi. But again, the cot function is not defined at 0 or at pi. So that means in this range we need to exclude those endpoints. Now let's look at secant inverse. So if you remember the graph of y is equal to secant x, then the domain is the range of that function is all the real numbers except the numbers lying in the interval -1 to 1. So that will be the domain of the secant inverse function, r minus this interval. So now again, for the secant function, just like the cos function, we choose the same principal value branch because secant is just reciprocal of cos. So we choose the same principal value branch here. However, note that cos of pi by 2 is equal to 0. So that means secant of pi by 2 is not defined. So which means that we should exclude the point pi by 2 from this range. Then last one is cosecant inverse. So here the domain will be the same as secant inverse, and also the range of this function, it will be, since cosecant is 1 over sine, then the range of this function will be the same as the case for sine inverse. But then again, notice that the sine function is equal to 0 at when you pass 0 as the argument. Sine of 0 is 0. So cosecant of 0 is not defined. So we need to exclude this point from the range. So yeah, these are the domains and ranges of all the all the inverse trigonometric functions which we had defined. So now let us solve some simple problems based on these inverse trigonometric functions. So let us say we are asked to find the value of cos inverse of minus half. So yeah, basically what this question is asking, we need to find an angle whose cosine is equal to minus half and one that lies within the principal value branch of the cos inverse function. So we know to begin with, we know that cos of 60 degrees or cos of pi by 3 is equal to half. And but also we need to find an angle whose cosine is minus half, not half. So for this we basically make use of this property, cos of pi minus theta is equal to minus of cos theta. So if you put theta is equal to pi by 3 in this, we get cos of pi minus pi by 3 is equal to minus cos pi by 3. Cos 2 pi by 3 is equal to minus half. So and yeah, and now we need to check whether this angle is within the principal value branch. So that is so the principal value branch of cos inverse function is 0 to pi. So clearly 2 pi by 3 lies within this. So that means this angle is our answer. We can write cos inverse of minus half is equal to 2 pi. And this is our answer. Now as another example, let's take this one. We are asked to find tan inverse of root 3 minus secant inverse of minus 2. So so we need to evaluate two inverse trigonometric functions here. Here we know that tan of pi by 3 or tan of 60 degrees is equal to root 3. So this angle is within the principal value branch of the tan inverse function. It is minus pi by 2 to plus pi by 2. So that means this angle will be the answer for this first term. Tan inverse of root 3 is equal to pi by 3. And now for secant inverse, we find it, I think it will be easier to work with cos first. We already know that cos of pi by 3 is equal to half, and also that from the previous problem, cos of 2 pi by 3 is equal to minus half. And this implies that secant of 2 pi by 3 is equal to minus 2. And remember that the principal value branch for secant inverse was 0 to pi minus pi by 2. This angle clearly lies within this principal value branch, so that means this is our answer. So we write secant inverse of minus 2 is equal to 2 pi by 3. So now we have the answers for this first term and the second term. Now we just need to combine them. So the final answer is pi by 3 minus 2 pi by 3 after you substitute into this expression, and that is equal to minus pi by 3. So with that, we complete our first lecture on the topic of inverse trigonometry. Now in the next lecture, I'll be covering some more identities in inverse trigonometry and going deeper into the topic. So thanks for watching and bye for now.